aggressive. I probably wouldn't be quite that aggressive, but we want to get you guys some fast results here. So you can see though, a little more clearly. So we got this whole section machine. You can see it looks pretty nice.
And then the other thing to note is that you can see on this edge, it has these sharp edges. So I'll actually bring this table forwards.
And we're gonna file them off.
This is, I don't know if you guys are made aware, but this is called edge breaking. So we have a pretty sharp edge there. And now what we can do is take the file. The file usually only goes in one direction and you just bring it over like that. That's a pretty significant edge.
Yeah.
More aggressive file.
Yeah. So, but basically you wouldn't want to touch that. So if you taking off the machine or something, you would use a piece of cloth usually, or you'd grab it from somewhere that wasn't machined, because it can be nice and sharp.
Yeah, I don't know if you guys can see, but it's like a
razor. There's a decent amount of buildup there.
It's like a razor thin. So with something that large, get a more aggressive file like this, and then you just knock the edge off. I'm going to put this in a vise.
Okay. So yeah, so if you want to file in a more specific way, you can actually clamp down your part and then do the filing. Are there any questions so far about what's been going on?
And now it'll be harder to see, but you can see how nice that edge is there. So these edges basically have an unknown length, but a very nice little chamfer. Like corner chamfer. It would be like a 30 thou, maybe 50 thou corner chamfer. So this is a nice flat surface here that's been machined. And then this surface here is parallel to this surface here.
Because that was clamped down.
Because this was bottomed out on the vise. But then as you can see where we didn't machine here, it's not parallel. So this section here and this section there are parallel, and then this section here is not. So, it's something to note, but then you can still, and we could go back to the mill and do it. With the way this is set up now, you can actually still clamp this in the vise because the vice's jaws are parallel.
Yep.
So, this is kind of a worst case scenario, but it really kind of shows you where things become important. So,
and it really depends on, the fidelity of the part you're doing, how much you care about things like squareness. If you want to, go all the way with doing a part really nicely, or it has a specific functionality, then you might care a lot more than if you're just kind of playing around, like palling around in the shop like we kind of are now. So just keep that in mind too, that whatever fidelity that you want to do something to, you're usually paying for if you get a manufacturer, because it takes more time to measure things and be more precise than it does to just throw it in there and do something random to it.
Yep. So now one important thing to note, and we'll actually grab a brush and clear off these chips. Just because as we put this in, if the chips are in there, they'll throw off our squareness. So, but remember, when we put it in the vise, we put it with this bad edge here, this bad lip, which is sticking out. We put that off the vise. So this here,
the top part we
machined is only parallel to this surface if this corner here is not touching. If it was touching, it would actually, they wouldn't be parallel because the line goes from this corner to that corner and is not, right, is a very shallow angle there. So when we set it up in the vise, we'll actually set it up so that, again, this corner will be off the part, and then these two parallel jaws will grab the parallel surfaces there. Again, we don't have any location this way, so now this is where using a parallel comes in.
We're gonna grab a parallel. Also, something to think about too with, for example, when you want to like chamfer those edges. So that's an option when you go to a manufacturer. You can ask for broken edges, or you can break them yourself. Sometimes it's more fun to get it right off the machine with the unbroken edges, because then you get to see the process a little bit cleaner. So there's all kinds of options when you go to a contract manufacturer like Xometry or Proto Labs or Fictive. And so all those options are things that you consider when you're ordering parts. So these are some parallels. I can grab one if it needs.
So this is now on these kind of heavier set parallels. We're gonna snug it down, and then you just give it a little knock, and the parallels, you just want to like kind of gently tug on them to make sure that these parallels don't slide in and out. So it's actually resting on the parallels, both of them correctly, which means that bottom face is now parallel to the bottom of the joist, parallel to the bottom of the table, and everything's square and perpendicular. You would hope.
Yeah, there's always going to be some amount of imperfection.
So now what we can do is work on this face here and maybe these edges here. But and another important thing to note is that now our DRO again is off. So when we change positions or change something in the vise, we have to reset the DRO. Right?
Every time.
If I move this back
to the
zero,
doesn't mean anything anymore.
Yep.
We moved everything. So like here we are moving it in the X and Y, pretty close to 0. That's, I mean, good enough for the government work.
Yep, close enough. It's basically 0, 0. And you can see it's not
all
anywhere,
the way off the part.
Not anywhere close to the part. So this is where, you'd have to come in and do some edge finding. And again, if you did edge finding to an edge that isn't straight, right? So if I edge found in the middle and then my hole is up here, but it's supposed to be a 1/4 inch in from the edge, it might actually be like 3/10 or 0.4 in from this edge here, if it's a 1/4 inch from this edge here, if this is where I did the edge finding. So stuff to balance, things to think about. For most people, they're not going to get that much into it. If you start with a really nice piece of stock, you can take most of this for granted.
Yeah.
But this shows you why it's necessary. So now I'm just going to tighten this up all the way.
Any questions or thoughts before we go on to the next part?
Center drill?
Yeah.
Okay.
Yes, we can hear them. They're just muted. Do you guys have any questions? Seriously, don't be shy. No? Okay, just having fun? All right. Hopefully this is a nice change from the finals week, doing all your work. We're trying to make it interesting, so hopefully it is.
One thing I've just done, something to be aware of, and it happens to everyone.
Oh, yeah.
I've loosened this up just a little bit. If I loosened it up too much, my end mill might just fall out. And if it's an expensive end mill like this one,
you don't want that to
happen. It's a hard
happen.
Table, that can cost you some money there. So
you hand loosen
it a little bit. Now I just kind of loosen it the rest of the way. And this end mill still isn't coming out, which
is also pretty classic.
So you can give the top a little bump, and you can see if I didn't need to do that, if it wasn't frozen, it would have just fallen out onto the table.
Yeah.
And then this here is still being held in, so I have to keep loosening the top side until it drops out like that. So
if you ever get stuck, just remember this. It's a cool one. If you ever are in the shop and someone's like, oh, I can't get out my collet or whatever, you look really cool when you walk over and just give it a whack on the top. They're like, wow, you just saved my day. So that's what I always like. People always forget that you can do that. So if you're having trouble getting it out, that's the move. So now we're switching out for a different collet that has a center drill in it. So we talked about center drilling a bit together. So it has like a really, really short nub so that you can get your hole started easily, and be more confident that it's going to be stiff and short. So this is our center drill. There are a couple of different sizes based on how big a hole you were trying to do. We were kind of doing something arbitrary just to play around, so we don't really care too much.
Yep. So now we're going to do a little bit of pretend, and we're going to re-zero the pull to this top corner here,
Yep.
which isn't square again, but
But we're pretending it is now. So
Pretending
we've
it is.
machined the whole thing. It's nice and square. And so what Dan's doing now is bringing the quill down. So that's what he'll use for what's called peck drilling, which is the technique of going in and out.
and with a center drill, like with a drill bit, you would usually peck drill.
Right, with a center drill. You're not
But with a center drill, you're just getting the hole started. You're just kind of saying, this is where I want the center of my hole. I'm not actually trying to drill the full hole.
Right. But this quill comes in handy for when we do that other step. And you can also lock it so it can't move in the Y direction anymore. Or sorry, in the Z direction anymore.
Yep. So here, I've kind of moved this to the top corner. It's close enough.
So this is an approximate 0, 0.
Yep. And so now what we're going to do is we're going to go about 2 inches in and then probably maybe 1 3/4 inches down. That should be close to the center here. So let's see how that works out.
So we're going in on the X, so you can see the numbers are changing. Just kind of get used to which is positive, which is negative. Every time before you move the handles, I kind of think of the right hand rule in terms of which way you want to move, counterclockwise or clockwise. So we moved about inches,
and that's
about the middle. Because remember, it was about 4 inches long apart. And then now we're moving like closer to us, which is the negative direction based on where we set our DRO. Because if this is 0, 0, that was positive. Oh, sorry. I'm like, if this was 0, 0, that was positive in the X and negative in the Y. I'm going from
right.
there.
So we're in like, you remember like algebra.
Your quadrants.
You're in like quadrant 4 right now.
Yeah.
But if we had set 0, 0 there, you'd be in quadrant 1. So anyway, so we're 2 over, minus 1.5 down.
And we look pretty close to centered on the part. Not that we really care that much, but
we're gonna pretend.
Yeah.
Check to make sure everything is set correctly. Alrighty, so now this is an aluminum component, so it really, I'm just gonna drill.
Don't change the speed unless it's on. So good things to remember.
Exactly. So we're just gonna get going now.
I'm gonna go other side.
You can see the point is actually starting inwards. It makes a very nice, start for the hole. And that's it. And we're now center drilled.
It wasn't focusing super well there, so I apologize, but I'll show you guys up close here. So there's our hole. And then, there's our center drill that now has some new new chips on it, so you can tell it's been used. So now we're gonna swap it out to do our actual final hole diameter. So we're gonna take out the collet and the.
So one important thing to note actually is we could take out the collet. We could just drop. So right now this hole is right below the spindle, and the spindle, the drill bit can't really move the table at all. Like it doesn't have the power to do that. Only the feeds, right? Only our handles can move the table, which meant if we bumped any of these handles, it wouldn't be centered, which means our drill bit would go in off center, bend in, and probably break. That would be very bad. So you could use these locks to prevent it from moving at all. These will lock the cross in the fore aft.
Yeah, there's one over here too.
The other thing I usually recommend doing this with your milled piece is you do your center drilling to keep it accurate, but then for the actual drilling operation, you want the vise to be able to move with respect to the drill bit. So we'd actually go and clamp this in a vise that is free to move and then use a drill press to drill it. So that's probably what we're going to do now.
Cool. So as he is removing the piece, let's see, there's a couple of drill presses. Which one do you want to use?
Let's use
the big blue,
the big one.
Big blue,
actually,
or this one. I kind of like this one. It's cute. Sorry, we're having a little
sidebar here.
Extemporaneous. Oh, they have a nice magic magnet. Anyway, so yeah, so drill press, very, very. So you can do drilling directly on the mill, as we were just saying. And that can be helpful when, as Dan was saying, if you actually wanted everything super like set in, locked down. But like he was saying, it can be very advantageous for the piece to actually be able to drift just ever so slightly, so that you don't break the drill that you're using. And so because of that, we're over here on the drill press. So we're going to clamp our piece down to the table, put the drill in, and then we're going to get really, really close to where it is, but ultimately let it move a tiny little bit to actually center it correctly.
Okay, so one quick note before we get there, just to it seems silly, but
What's the note?
show everyone what is
calipers. Yeah, so we're gonna get out some calipers.
So some tricks that you guys may or may not. I'm not sure.
What the background is of everyone.
What the background is of everyone. If you guys have used calipers or not. Most people, this is very good at measuring outside diameters, outside dimensions. So this is like 4.73 millimeters. Actually, don't know if this caliper switches. It may not.
You will find, similar to what we're experiencing right now, there are a large variety of caliper qualities, and also how well they've been maintained.
This is only metric, which is fine. I'm gonna go grab a different one.
Yeah. So yeah, when you're working in, like, for example, room 36, or if you're working in the main shop, the calipers you can get the electronic ones. You can also have the manual ones. So there's a lot of different options there. But the main thing you want to think about when you're using calipers is that as you're measuring something, you're going to apply a certain amount of force. You want that force to be the same as when you zeroed it. So every time you get the calipers, you zero them first, and you try and approximate as best you can the amount of force that you're pushing them together with, and then you zero it there. And then when you actually have whatever piece you're trying to clamp down, you want to, it's so inexact, but you want to try and feel as if you're putting the same amount of force on there so that you can be relatively confident in your readings. Depending on how expensive they are, calipers can give you a variety of precisions. So you can get calipers that'll go out to multiple digits. You can get ones that'll just do like a 100th probably of an inch. So just something to keep in mind as you use them throughout. And you might choose like what kind of caliper you need based on how much you care about that dimension. So yeah, let's see. I'm just
This seems to be the only one with batteries. So
okay, so we're going with the metric one.
On the fly with the metric. So this should be about 50 millimeters in from this corner here, and you'll see a lot of people like this is really good for measuring outside dimensions, like we were saying. So 4 inches is about like 102 millimeters. This is like 160. We're close. This, you can see if I'm holding this caliper this way, you guys know your Pythagorean theorem. If I have it at an angle, this is not exact. It's about 50 millimeters, which is about 2 inches. Another trick a lot of people don't know about calipers, you can use this to find hole depths. So for instance, how deep did this hole go? Set that up like that, bring the edge down. It's 2.75 millimeters deep. But okay, so how do I actually know the location of this hole? This is the wrong way to measure the location of this hole. Calipers actually kind of have this hidden feature not a lot of people know about. Also, this is good for inside diameters. I know I'm getting backtracked, but I'm working up to it.
No worries.
So, that tells me that this was about a 6 millimeter hole that got drilled. It's actually probably a 1/4 inch.
That's a different hole, by the way. There was a hole already in the piece.
Right,
we did not do a 6 millimeter hole with the center drill.
So then what we can do though is use this back face here, and these are ground to be, when this is closed, these tips match, and then these are ground to be flat. So you can actually use this as a step like this and go, and now you know that your reading is actually parallel to the surface. So that's actually correct, and that's 50.24, a lot more accurate to what we did. Likewise, we can go from this side, and again, if we have the caliper there on the back, well, if we have the caliper on the angled piece, you can see it's angled. It's not square to the stock, but if we have it from here, we can bring it in, and it's about 1.5 inches. 25 plus like 12.7. So,
all right.
Yeah. So now what we're going to do is we're going to drill. So, this is a pretty standard drill bit. Just put it up.
So drill bits can be in letters. They can be numbered. They can be fractional. So I guess the number would be decimal. So there's a
Yep.
lot of different ways to
Well,
figure out which.
And they can be numbered or they can be decimal.
Right.
So
Yeah.
so this is a number drill bit. This is a number 12 drill bit.
Oh, they're not gonna be able to focus on that.
They probably can't see that. But a
But
lot
anyway.
of most drill bits will have readings on the sides
Yeah.
where it'll tell you exactly what it is. Like this is a
So if you ever forgot or something and you're trying to put it back away,
12.5 millimeter drill bit.
look at it first. And similarly, if you pull it out from somewhere in the PRL and you're like, this doesn't really look like it's exactly right, I would always check the shank to see if you can figure out exactly what it is.
I don't know, maybe.
They really can't. I mean, okay, I guess you can kind of see a little bit of, yeah, you can see USA, I think. Sorry, the camera does not focus well, but you guys get the idea.
This is a letter Z drill, so you guys know. Anyway, so now we're gonna put it in the chuck here.
So this chuck,
and this chuck doesn't tighten up all the way with your hands because obviously I can spin it and that's not that tight.
Yep. So we need the little key. So we're gonna look for it really quickly because we were very prepared for this session, and looks like we found it.
No,
not yet. Okay, we are still looking for the key.
Oh, here it is.
Ah, we have found the key.
So usually a lot of shops, I don't know if PRL does this, they'll like
it's
attach the key somewhere so no one can walk off with it. And this cable's broken, but so now what I'm doing is I'm putting the key in here and I can actually now tighten this. I don't know if you could see these teeth moved, so I can tighten the chuck on this drill. So key drills are pretty nice. This is the vise we're going to use.
So, but like we were talking about, we want a vise that's like nice and heavy, not going to move a ton, but allows some kind of give, so that the thing that isn't going to move, so that the drill isn't the thing that's going to move the drill bit there. So we're adjusting the height now because we tried putting everything on and it was too high.
And then one thing to note, so we now know that this will come down and drill our component. This stop here on this side, you can use to set how far
you want it to go.
So, now it bottoms out on that. And then the other thing you want to make sure is that it's not going to drill into your vise. No one likes no one likes drilling into the vise.
So a lot of people, a piece of wood under it if you want to.
We'll put a piece of wood underneath the component so that way you drill into the wood and not your vise. That way it's also kind of blocked up as if it was on parallels.
Yep.
So yeah, that's one thing to note. So we'll get this going.
Any questions here, guys? Okay. Y'all have been awfully quiet. But I'm going to take that in as you're just taking lots of information.
So this vise is a little interesting. It actually has a cam motion, so there's no screw or anything. You just unlock it. This slides back and forth, clamp everything in. And then this will actually not only clamp down on this so it doesn't move, it actually pushes it forward so it clamps on your piece as well. And then you can see as this drill bit comes down, this vise is free to slide as it needs to have the drill bit line up. So this table is perpendicular to the drill bit, and the drill bit, the drill bit is the only kind of locked feature on this table. So everything else can move to align itself perfectly with the drill bit. So now,
that being said, you still want to get it close.
You do want to get it close. You want to kind of, and I don't know if you guys can see, but I can actually bend the drill bit. It's not the end of the world. The drill bits have the ability to deflect, but
a
the
tiny
drill
bit, but you just don't want to do it too much.
Yeah, you don't want to do it too much. So,
because if you think about your beam bending equations, this is essentially just a very long, skinny beam.
Yep. That is rotating.
That is rotating.
So anyway, so now we're going to get this drill going. Come down.
So we're peck drilling. Oh, beautiful sound. Sometimes you want to wear earplugs. Alrighty. So you can see we have all those chips all gummed up there. I mean, that's part of why you want to do peck drilling, is to be able to let some of those chips escape as you go into the parts there.
And so as we're setting up a blind hole here.
Yep.
So
which means it didn't go all the way through.
It didn't go all the way through. And that's because we came up against the stop that we had set earlier here. So, the stop set the depth.
Couldn't go any farther.
And then, I don't know if you guys can see, but there is a slight lip
kind of difficult
around the edge. It's like,
it's a little bit raised. I don't know if you guys can tell. Maybe tilt it a little bit more, Dan, so we get more yeah, I think you can kind of tell. Yeah. Anyway,
like if I slide like this wooden block across, you can see it actually like
meets some resistance there. Yeah.
So that's raised. And so what you would then use is a deburring tool or a countersink to remove that around the inside of the hole there. So
yeah.
Example of a
deburring tool. This guy.
So you just set that up in there. Again, run this around. And just like edge breaking, this basically does the edge breaking, but on the inside of a smaller diameter hole. So, it's
a little bit less raised.
It's hard to see. Well, it's not raised, and now
it's actually got a little bit of chamfer on there.
A little bit of a chamfer. So
yeah.
Yep.
And then the other thing too, we'll just mention briefly, is that if you really wanted to get a very precise diameter, you would actually drill your hole a little bit smaller and then use what's called a reamer to remove the excess material there. So it's got a lot more teeth along the length of it to remove material, and it can only remove a very small amount, but it'll get you a more exact hole. So if that's really critical, like for example, Cooper, I'm thinking of your camping coffee French press, you might want something that was reamed, just because it'll get you a more exact hole diameter. All right, well, we're coming up on the 3-minute mark here. So I just wanted to see if you guys had any questions, and otherwise I think we'll start to wrap there. But yeah, any questions or comments, things you found interesting? If we do this again, like anything we should consider, get better lighting?
I don't really have any questions, I don't think. I thought it was really good. I appreciate how you guys really explained everything as you were going. And I thought it was really cool to just see everything.
Sweet. Thanks, Grace.
Yeah, I agree. I liked getting the piece of aluminum square in the mill was neat. That was kind of helpful to see how that would happen, for sure.
Awesome. Cool. All right. Well, yeah, so I'm going to say again, thanks to my special guest, Dan.
Nice to meet you guys.
For helping me out today. Give you guys a demo, and thank all of you guys for being such great students this quarter. This is being recorded, so I will make it available to all the other students who aren't able to make it today. But yeah, if you have any feedback you want to give later, feel free to email me or whatever. And otherwise, I hope you guys have a great rest of your quarter. Wrap everything up nicely. Today's the last day, so it should be go party tonight. All right. Thanks, guys, for joining.
Thank you.
Yeah. All right. Take care. Bye.